Let's look at rationalizing the denominator. So this method involves manipulating a fraction such that there are no thirds in the denominator. So let's look at some examples. The first example says 3 over root 12. Now when we have a fraction and we're trying to manipulate this fraction, whatever we do to the denominator, we must also do to the numerator. One way to get rid of the third in the denominator here is to use one of the third laws, which says that the square root of x multiplied with the square root of x equals to x, where x is greater than or equal to 0. So in this case, if we have the square root of 12, if we multiply that by itself, then we would just end up with 12 on its own. So what we do with this fraction is we manipulate it in the following way. 3 over root 12 multiplied by, so remember when we multiply the denominator by root 12, we also need to multiply the numerator by root 12 so that the value of this fraction doesn't change. This is like multiplying by 1. So we have 3 times root 12, which is equal to 3 root 12, and then the square root of 12 times the square root of 12 is just equal to 12 using this third law. Or we can also think of this as root 12 times root 12 is the square root of 144, which is equal to 12. We can simplify this further, so we have 3 without a square root and 12 without a square root. The largest number that goes into both of those is 3. So 3 goes into 3 once, and so we'll just be left with 1 times root 12, which is root 12, and 3 goes into 12 4 times. So this is root 12 over 4. The square root of 12 is the same as the square root of 4 multiplied with the square root of 3, and then we have this all over 4. The square root of 4 is the same as 2, and so we end up with 2 times root 3 in the numerator, which is 2 root 3, and then 4 in the denominator. If we now further simplify this, 2 goes into 2 once, 2 goes into 4 twice. So this now gives us the square root of 3 over 2. And so what we've done is we've rationalized the denominator in this fraction to give us root 3 over 2. So we see that the denominator doesn't have any thirds within it, and this is the simplest form of this fraction. Alternatively, we could have simplified this in the following way. So we have 3 in the numerator, and in the denominator, root 12 can be written as the square root of 4 times the square root of 3. This now simplifies to the following. So 3 in the numerator, root 4 is the same as 2, and 2 times root 3 is 2 root 3. Now to rationalize this denominator, we need to multiply the numerator and the denominator of this fraction by the square root of 3, so that we aren't left with any thirds in the denominator. So we now have 3 over 2 root 3 multiplied with root 3 over root 3. This is like multiplying by 1, and so we're not changing the value of this fraction. 3 times root 3 gives us 3 root 3, and then we have 2 root 3 times root 3. So this leaves us with root 3 times root 3, which is 3, and then 3 times 2, which is 6. And now finally, if we simplify this fraction, we end up with root 3 over 2, since 3 goes into 3 once and 3 goes into 6 2 times. And this is exactly the same answer that we got using the previous method. In the next example, we have 5 over the square root of 6 plus 1. Now when we have a fraction like this, where we have 2 terms in the denominator, we need to multiply by the conjugate. So the conjugate of this denominator is the same 2 terms, but with the sign swapped over. So in this case, root 6 plus 1 and root 6 minus 1 are conjugates. Likewise, if we had any 2-term expression, so for instance, root 3 minus 1, then the conjugate of this is root 3 plus 1. If we had 2 minus root 5, then the conjugate of this is 2 plus root 5. And if we had algebraic expressions, such as square root of x plus 3, then the conjugate of this is the square root of x minus 3. And if we had the square root of 7 minus the square root of 10, then the conjugate of this is the square root of 7 plus the square root of 10. Each pair of these expressions are called conjugates. In other words, two-term expressions where the signs in between the two terms are opposites. Therefore, to rationalize this denominator, we would have the following. So we have 5 over the square root of 6 plus 1, and now we need to multiply the numerator and the denominator by the conjugate of this denominator. So the conjugate of root 6 plus 1 is root 6 minus 1. So we multiply this fraction by the square root of 6 minus 1 over the square root of 6 minus 1. This is like multiplying by 1, and so we're not changing the value of this fraction. If we were to now multiply this out, 5 times root 6 is 5 root 6, and 5 times minus 1 is minus 5. And in the denominator, we have the following. So root 6 times root 6 is 6, root 6 times minus 1 is minus root 6, 1 times root 6 is plus root 6, and then 1 times minus 1 is minus 1. We can now simplify the denominator here, so we have 5 root 6 minus 5 in the numerator, and now in the denominator we see that minus root 6 plus root 6 cancel with each other, and so we're left with 6 minus 1, which is equal to 5. We can further simplify this fraction in the following way. So we have two fractions, the first being 5 root 6 over 5, and the second fraction being 5 over 5, and we're subtracting the two terms. And so finally, if we simplify both of these fractions, we have 5 goes into both the numerator and the denominator, and so we're left with root 6, and 5 divided by 5 is 1. So we have minus 1. And so therefore, if we rationalize 5 over the square root of 6 plus 1, we end up with the square root of 6 minus 1. So in this case, we don't have a denominator with any surds in it. If we wanted to think of this as the denominator, we could think of this as root 6 minus 1 all over 1. But a simpler way to write this would just be root 6 minus 1. And so we don't need to include the 1 in the denominator. In the final example here, we have 7 over 3 minus 2 root 2. And so in this case, what we need to do again is multiply by the conjugate of the denominator. So in this case, the conjugate is 3 plus 2 root 2. And since we're not changing the value of this fraction, we need to multiply both the numerator and the denominator by the same conjugate. So in this case, 3 plus 2 root 2 over 3 plus 2 root 2. If we now multiply this across, we have the following. So 7 times 3 is 21, and 7 times 2 root 2 is equal to 14 root 2. So that's what we end up with in the numerator. In the denominator, we have the following. So 3 times 3 is equal to 9. 3 times 2 root 2 is equal to 6 root 2. Then we have minus 2 root 2 times 3, which is minus 6 root 2. And then we have minus 2 root 2 times 2 root 2, which gives us the following. So root 2 times root 2 is 2. 2 times 2 is 4. Times the 2 again is 8. And we have a minus here, so we have minus 8. Simplify this fraction further, we end up with 21 plus 14 root 2 in the numerator, and in the denominator we have 6 root 2 minus 6 root 2, which cancel with each other, and so we're left with 9 minus 8, which is 1. And so this can be simplified to 21 plus 14 root 2. And so again, we've rationalized the denominator of the fraction 7 over 3 minus 2 root 2, which gives us an answer of 21 plus 14 root 2.